Hello everybody. Today we're going to be talking about global winds. Alright, so some things to remember before we get started are that when winds blow, they always blow from an area of higher pressure to an area of lower pressure. Right, if you recall, we talked about a balloon. If you blow up a balloon, it's going to have a very high pressure, but if you release that balloon, all the air is going to rush out towards the lower pressure. Also, we discussed the Coriolis effect, and what happens here is objects, especially the wind, are not attached to Earth, so when wind is blowing across Earth's surface, the Earth is rotating below it, and it causes the winds to turn or to curve. We also know that Earth's polar regions, meaning the North Pole and South Pole, are very cold, and the equatorial region near the equator is an area that's very warm. Okay, so here's a scenario. If the Earth were all water and did not rotate, then winds would flow directly from the poles to the equator in a straight line. At the equator, air would rise up due to its lower pressure from being warm, and at the poles, air would sink due to its higher pressure from being cold. So what I want you to do is I want you to complete the arrows in your notes if they are not already there. Okay, so starting at the North Pole and the South Pole, we have high pressure, and this is because the area is so cold. And then also at the equator, we have lower pressure because the area is very warm. Now, this scenario is what would happen if the Earth did not rotate, which, of course, is not accurate. So what happens is your high pressure would blow towards your area of low pressure, right? The equator, low pressure, because it's very hot. Also, South Pole would blow towards the equator, right? So it's going from an area of high pressure to an area of low pressure. Now again, this does not actually happen. This is what would happen if Earth did not rotate. Since the Earth does rotate, here's what really happens. So, due to the Coriolis effect and the rotation of Earth, what happens is the winds curve as they move from areas of high pressure to areas of low pressure, right? And this causes something called the wind belts, or the global wind belts. So this is what causes Earth's winds to turn or to steer its way around the globe. All right, make sure you complete all of these drawings in your notes if they are not already there. Okay, so we have some extra latitudes that were not included earlier. First, we'll start off with the North Pole and the South Pole. Right, we know that they must be areas of high pressure because they are so cold. We also know that the equator is very warm, therefore it's going to be an area of low pressure. And then we also have 30 south and 30 north. Those are also going to be areas of high pressure. 60 south, 60 north are also going to be areas of low pressure. So what we're going to add to our drawing first is I want to draw some L's for low pressure. Actually, I'm going to erase those and do that in red. We should associate low pressure with warm. Also at 60 north, low pressure. 60 south, low pressure. All right, low pressure we talked about is always going to be associated with clouds. Therefore, it's going to be a wet, rainy area. I'm going to switch over to blue now, and I'm going to draw some H's where my high pressure areas are. And then finally at the bottom, South Pole, North Pole are going to be high pressure. Right, and high pressure is always associated with dry weather. Right, remember we said happy, high, cool, and dry. So what I'd like you to do is I'd like you to take out your Earth Science reference table and turn to page 14 if you did not already do so. If you look on your reference table, there is, in the center of the page, it says planetary wind and moisture belts in the troposphere. And if you look to the right, there is a circle which represents the Earth, and there are your wet and dry belts, as well as the arrows that represent the direction that the wind flows towards. Okay, so we're going to start with the 30 degrees north latitude. And what we're going to do is we're going to draw our arrows moving away from the high pressure areas. So if you recall, high pressure equals clockwise and outwards. So that's what I'm going to do, and that's in the northern hemisphere. So I'm going to draw my H's. They're going out and clockwise, so they curve to the right. Same thing down here, so they're going to curve as they move away from the area of high pressure. Okay, you can kind of see that they're rotating around clockwise. All right, we're also going to add the one for 90 north, and if you look in your reference table, it kind of moves in that direction. So it's curving around to the right. Now in the southern hemisphere, you'll notice it's a little bit different. In the southern hemisphere, it's actually opposite what we're used to in the northern hemisphere. So the high pressures are going to rotate counterclockwise, but they still do go outwards. All right, and then lastly, the South Pole. Okay. So these are the different directions that the wind blows. So these are our planetary wind belts, and as well as the moisture belts, so the areas that are wet and dry. Okay, so this is like looking at Earth's surface from the side view. So we're going to focus on the equatorial area, so the equator down here. So if you were standing at the equator, we know it's an area of low pressure. Therefore, low pressure is going to rise, right, because it's warm and moist. When warm, moist air rises, you got it, clouds start to form. Right, and because clouds form, you also get lots of precipitation, which is why the equatorial area is where we find most of our rainforests. If you also look over here at 60 degrees north, remember this is also an area of low pressure, and you'll see here that the arrows start to rise. So that shows that the warm, moist air, I guess not necessarily warm, but it's still moist, air is rising, and you also get rainforests here. They're not considered tropical rainforests, they're just rainforests because they are cold, but they still rain a lot. Okay, so now we're going to focus on 30 north, which is an area of high pressure. And if you recall, high pressure, right, air is more dense, so therefore it's going to sink. And if you have sinking air, that means you have no clouds. Right, so that occurs here, and that means that 30 degrees north is going to be an area that's very dry. So most of our deserts are located around 30 north. Also, you might not think about it, but 90 degrees north and also south, near the North Pole and South Pole, there's sinking air there as well. Therefore, that means they are considered deserts as well. Okay, so I'm going to draw the equator first, so I'm going to do that around here, so that's about 0 degrees latitude. I'm also going to draw 30 degrees south, 30 degrees north, and then 60 north, 60 south. That looks pretty good. So that's close enough. So you'll notice that where the equator is, I did it in red because it's very warm. You also get lots of cloud formation. So this area right in here is going to be very wet. right? And that's exactly where most of our tropical rainforests are located. Also, if you notice up here at 60, I guess I could write 60 degrees north, is also going to be an area that's very wet. Also 60 degrees south is an area that's going to be very wet because the air is rising. So these aren't considered tropical rainforests, but they are rainforests because it does rain often. If you look at, I'll change the color to 30 north and 30 south, these are areas that are very dry. And you'll notice this is where we have most of our deserts, specifically this one right here, which is the Sahara Desert. It's exactly on 30 north, which is where high air pressure sinks. Okay, another factor that is caused by all of this air movement is something called the jet stream. And if you recall, or look in your reference table between 30 north and 60 north, which would be just about in between here, you'll notice that the arrows go in that direction. This is important for all of our weather systems in the United States because most of our, or all of our weather moves from the southwest towards the northeast. So a storm out in California over here in a few days is eventually going to make its way towards the east coast. So if it's raining right now in California, it might take 3 or 4 days for that rainy storm to get over to where we are in New York. Okay, so I want you to take a second and I want you to look at the latitudes in your reference table, and I want you to figure out where New York would be located. So what latitude is New York? If you recall, New York is approximately 42 degrees north. So that means it would be somewhere along here. And again, that goes to show that we have southwest winds, meaning that they move from the southwest towards the northeast. So all of our storms would track in that particular direction.